atomic particles and making them dance together more with each other, like orienting them one with another. So it's a level deeper than NMR.
Yeah. Yeah, I'm just saying though, this is what I had to do this lab about, and you have to like basically you have to do the brackets for
That
for the
that's
equation,
what
and you get
99% of the entire field of nuclear science, like radioscopy science, spectroscopy, deals with NMR and stuff like that.
well,
Which is
it's
why you
crazy
talk to
because
ChatGPT, he doesn't know anything about DNO or DNP, doesn't know anything about dynamic nuclear polarization.
yeah, but I know, but it's just crazy that you can tune in with this spin, just a magnetic field. You can tune into hydrogen atoms, put a sample in there, and be able to tell what's in that sample next to the hydrogen atoms by tuning into the hydrogen atoms and just reading the frequencies back on them, because the wave function is literally all these perturbations of all the entanglements of everything in its environment at
I
once,
mean,
and that would
if you
be
look
like,
at the flag behind you, it's red, white, and blue. The reason why it's red, white, and blue is because the electron bands around each atom are reflecting, they're actually reflecting the entire spectrum, all the way down to the low terahertz to the upper terahertz, including X-rays and all of that. And there's specific lines where they reflect and other ones where they absorb. And it just so happens that in our visual spectrum, it's red, white, and blue. But there's a lot of other colors out there. There's a lot more to the spectrum. And
well,
that's
absolutely.
all to
Well,
do with
that's what you say.
resonance and
It's like
frequencies. It's all about
I've
every
got a
resonance and frequencies.
question. Does the
yeah.
red, white, and blue have to do with the fact that like white is the full light wave and red's infrared and blue's like ultraviolet on the opposite ends of our seeing spectrum? Or is that
Yeah,
unrelated to
yes,
it?
it does. That is true, but it's never true white because it doesn't reflect everything. It has like a squiggly line that shows you here it reflects here, it doesn't reflect here that much. But anything that involves enough colors reflecting back at you would our eyes would perceive as white.
So what happens is that the nuclear structure creates these wave patterns in the clouds that the electron can sit in. And when the electron jumps and drops from those different orbitals, it releases a photon, a specific frequency photon every single time.
Exactly.
And every atom is different based on the internal structure the internal nuclear structure. And so it has different orbits. And so it gives off different spectral emissions, and those spectral emissions can be used to identify what atoms are what. This is the basis of nuclear science, and you can do that
I've
with
got
the
one more question. Sorry, can you repeat the part, or is this correct? You said that when the electron moves from one orbit to another, like on the atom, it emits a photon when it does that. Did I hear that
yeah, when the
correct?
electron jumps between any one of these orbitals, it has a photon that it emits. Okay,
So-
and
yeah.
all that's affected by everything around it. It causes this hyperfine splitting of the bands. So each one of these bands isn't a single band. It's actually it's split into a bunch of different lines because of all the different micro perturbations of just what's around that atom's immediate environment can cause little tiny fluctuations in those lines, but they're almost always certainly dead on. Like they'll be like ones in certain positions, and that's how that's hydrogen, that's sodium, and sodium's good because it has a lot of spectrum in the visible light, so you can use it in lamps. That's why they build sodium lamps. Same with mercury, right? Mercury has a lot of useful visible light
And
emissions.
hydrogen, actually, mercury is a little bit higher in the UV, which is why you have fluorescent lamps. They're actually mercury lamps.
Yep.
They're mercury going in the UV, and then we fluoresce down to the visible.
What are the
So I've
ultraviolet
got
lamps made
another
out of?
question regarding that. Does
Ultraviolet are made out of mercury without fluorescence.
Oh,
I mean, but it's
so
dangerous. It can hurt you.
yeah.
So when
High energy.
metals and elements dissolve into water and become in their ionic state, and literally they, I believe it's with within the electron shell and band bonding within the water, is it not? Would that mean that every time an element is dissolved and undissolved, photons are emitted and taken?
Not necessarily.
Not necessarily, but you know what's interesting is if you hit stuff really hard, it emits photons. Like the pistol shrimp will, there's a flash of light in the supercavitation of the bubble that it creates when it strikes. So there's
There's also sonoluminescence, like when an air bubble
Yeah,
or a vacuum bubble in
sonoluminescence
water gets
happens
shots
in
together.
that pistol shrimp action.
yeah, it happens in other things too. Like you just you can you know, like not just crystal, you know, like crystals, like if you smack a quartz crystal really hard, it produces a spark. But there's other materials. If you it turns out that other materials are if you hit them hard enough, they do that too. Right?
Winterberg was obsessed about sonoluminescence inside of plasmas, because anytime you can create a cavitation that collapses on itself, that's where you have this squeezing of all the states, and that's where you can potentially get 0-point energy release. And
this is a good one, because this is a gap in the standard model, because the standard model cannot explain where the light comes from.
Yep, it's squeezing it all down. And there was this other postdoc physicist kid that I listened to. He was showing that it's like magnetar, very, very brief, but magnetar level magnetic fields, like 10 to the 15 Tesla, for an infinitesimal amount of time during the collapse of a sonoluminescent bubble. So if you imagine like a plasma that's super electrically charged and lots of magnetic fields,
yes,
right?
Jared, what you're describing is exactly the key to my thesis on the cold fusion with the plasma arc, the electrical arc between the two electrodes, your anode cathode, within an electrolyte in electrolysis. And that is where you're able to get that, well, the sonoluminescence and as well as that plasma confined within that bubble and the pressure density of the electrolyte salt water.
So if you, the pressure of your stuff matters, right? So if you do a sonoluminescent bubble up near the surface versus at the bottom of the Marianas Trench, you're going to have different results with that collapsing bubble, right? Because there's a lot more pressure to make it collapse, so you're going to get more of the effect, right? It's going to collapse harder, faster collapse, more light. Well, in a plasma, like a really dense plasma under extreme, insane pressures, you're going to have like this very nonlinear ramp for all of these emissions of electrons and magnetic fields, right? So if you, the Winterberg Schwinger idea is that you take a super dense plasma that has a ton of energy and you create a cavitation inside that plasma. And as it collapses, it will be able to interact with all of the fields that come off of that thing a lot more than water would. So you can like harvest the energy, right? You can convert that energy out of the collapsing bubble into momentum or electrical or magnetic energy in the plasma.
Bingo. I think
that's the key with the two electrodes in electrolysis with the plasma arc there is, and relates to a lot of what Bob Greenier and the Martin Fleisch Memorial Project's finding, and also Hutchinson's work, is that the transmutation happens right on that boundary where it's the metal element and the plasma or the EVO happening. And when you get that high enough electrical arc between the two, it contains some of both the salt and the water into your an ionized state there. So that's giving you your high density plasma, and that you have your hydrogen and oxygen being formed on one of each of your electrodes. So it gives a lot of different combinations and possibilities for transmutations within that high density, high energy, like heat, electrical, magnetic, everything right on that boundary there.
Then we haven't even invoked harmonics yet, right? Resonance states.
Well, that's the last part of my.
Oh, is it? Yeah. If you can extract that energy in a way that creates a harmonic in your plasma.
So I state that you have to put in the harmonic frequency of the metal element, its resonant frequency, into that reaction of the metal that you're going to be transmutating, and that is what gives it and puts it into that state and allows your atomic hydrogen to mix in with these metals. And I have to give you guys a proper demonstration of showing Sir Isaac Newton's different transmutational states of metals, and that a few of them, the metals literally turn into a pure jelly. So it's when it's in that, it goes from being in a solid metal element with a very low energy requirement to turn it into this powder slash like goo. When it turns blue, I believe that's oxidized. Red could be hydroxide, but different combinations. But the point being, it's your entire electrode turns into this like gooey state, and that you'll when it's when I achieve that state, it is surrounded. It's always the anode side that produces the oxygen, and that because I use a triple solenoid coil, I've got the triple electromagnetic fields the triple solenoid, which by putting the current through creates the magnetic field, which then captures the oxygen. So it's like there's a shell of oxygen bubbles around this goo, and that it's then putting in that harmonic frequency, resonant frequency of the metal element you want to transmutate it to, that allows your oxygen and hydrogen or atoms to
Who the heck's
fuse in.
this guy? I don't.
Sorry,
I want. Do you have any demonstrations or any things you'd like to share? Because I'll go back to Mark's presentation now. And I kind of got sidetracked talking about sonoluminescence, and now I gotta go look up. I found another
let's get
engineer
back
out
to
there.
this. So yeah, anti-gravity of present technology. This is the Elfon experiment, basically showing a way to connect us to explain this anomaly that was first discovered with dynamic nuclear polarization, which is again orienting the strong nuclear force, which takes up 99% of mass, strong nuclear force, what combines protons and neutrons in the core of the atom. And by doing so, we could explain why there is a problem with the relaxation times that was discovered by Overhauser. It's actually gravity that's causing the faster than expected relaxation time. So maintaining that oriented state and having gravity forced to do work on it would be anti-gravity. So we come in with anti-gravity with present technology. Now, this is basically describing an EPR setup, an electron paramagnetic resonance, or an ESR, electron spin resonance machine. And that's what we built over here is one of our early versions. And Jeremy called it the NMR EPR laminar spintronic alignment rig. That was our first electromagnet that we built out of a hunk of iron. Early tests on that, we saw about 17 or 18% weight loss with this rig over here on the bottom right. It was very crude. This is like before we got funding. It was just working off the seat of my pants, doing hybrid batteries at the time. Jeremy was laying tile, and we met up and played around with this stuff and saw some cool results. Jeremiah got involved as well back then, and then we got some funding. I was able to slowly phase out the hybrid batteries and start working on this more. We picked up this big electromagnet, weighs about a ton, and this is a S-band, or a C-band system around 6 gigahertz. The klystron ended up not working very well. The electromagnet had some deformations in the magnetic field, so we needed to fix that. And I used a laser light along with a magnetic field probe to map out all of the magnetic fields. And we made a color coordinated map of that, able to see the deformations in the magnetic field. We then used this information to create a vector line, and we used that to machine out from iron what is essentially a magnetic lens. And this went on the plates over here on the right on the electromagnet, and was able to fix all of those problem deformities in the magnetic field.
It's like a
Um,
metamaterial lens almost.
yeah. Next thing we got was our Faraday cage was finally completed. Here's Shirley, Jeremy Reese helped finally put that together. We got fancier and fancier equipment. We started getting involved with lab view, and the first run with the lab view, I cranked everything up to 10 and ran out of the lab to make sure that I'm not going to perturb the environment at all. And I came back to this. There was a strong signal showing in the system. And with
Right.
that, we overlaid many runs and we were able to, with a high degree of confidence, say we saw something. There is a there. There's a connection, at least with this specific setup. We saw a signal. We saw a change in weight as it swept through the magnetic field. This is not related to just a magnetic field. It only happened when a magnetic field and a specific RF
So
field
that's a
pulsing was happening, just as expected from dynamic nuclear polarization. And
It's
yay,
an
we saw
interesting
some.
distribution. It looks like what does the mass go up and then it goes down? There's
Yeah,
like
that's kind of what's expected too, by the theory that it would be possible to make the weight go up and down based on how the orientation happens. Again, we're not destroying the mass at all. We're just focusing it. So right before you go in focus, you're going to be out of focus.
well, you're going to make that dip peak a heck of a lot sharper and lower if you want to get negative mass and really like lift and do lift and propulsion.
I mean, as
Right.
soon as you get low enough, you should start to take off just from simple buoyancy, at least in
Imagine
atmosphere.
that, huh? We're that simple.
So this is our latest machine. It's actually new, looks even better than this right now. I can take over, bring the laptop over and show you guys what we're actually running right now. The machine is actually running at this very moment. It's been running the entire time. And here it is. We're running the same test at under a vacuum. It's 1.5 to the -2 torr. We have the ability to go even lower, but that turns on a turbo down over there, and the turbo causes lots of noise in the signal. So I prefer to keep it off. I don't think it really matters to have vacuum that low. These are the microwave signals. They're being read by our lab view system. We actually have it hooked up via GPIB cable in the back. It goes up to a computer, which is over there next to the alien face. And that computer then feeds back to this lab view system. So all of this data is being collected and being saved on the cloud. And then we have another computer on the other side of the building where we're doing data analysis. Many megabytes or gigabytes of data have been created from the system, and we're trying to pinpoint exactly where these signals are and how to improve them even better. So this is working in the S-band range, and the current setup, we're running at 10 kilohertz signal pulses. The frequency is 2.96409 gigahertz, and that's going into an amplifier over here, which then goes into a bunch of RF stuff into the chamber. And the reflected power is being read. The reflected power, how much RF the sample is absorbing, tells us whether we're achieving that electron spin resonance. So it's very important to look at all this data and try to figure out what exactly is going on. One of the next things we're going to be doing is we're taking a 3-inch copper pipe, and we're going to be turning that into a different type of waveguide. So this is going to become a transmagnetic 110 mode S-band waveguide. So the magnetic field is going to be going up and down in the center. In order to feed that, we're going to be coming in from the side. I have to drill a hole over here. We'll be sticking this thing on. It's going to get machined out. That's going to fit on here. And then there's going to be another some other waveguide pieces along with the tuning element. I have a guy out in California, Kurt Zeller, who's going to be helping us with that project. On his program, he's able to simulate it on I forgot the name of the program. This is our X-band system where we got positive results and wrote that paper. As you can see, it's also a piece of copper pipe. 1-inch copper pipe, by the way, resonance at 9.88 gigahertz. Good thing to know, right? So it feeds in from the side. There should have been a tuning element over here, but there wasn't. There is a an iris, and a good thing about this setup is it allows you to have very large samples. And the larger the sample, the more weight we have there, the better resolution we can have, because we can see it's a heavier sample, it's losing more weight, as expected. Over here we have a bunch of different samples that we can run in the future, various materials. So that's going to be fun as well. Another thing we have going on, and this is going to be in our go back to the presentation. Let me show them couple more things. Jeremy, can you pull up the presentation again?
Mark, you're gonna have to share it again. Oh, there it is. Sorry.
There it is. Okay. So the next thing is, that's just the view of what it looks like when we bring the sample in. That's this machine over here. This is actually a hand controller for a TEM, or transmission electron microscope. It was taken off a transmission electron microscope in order to be used in this machine. So this is another cool thing that we found, is that there is a method to increase dynamic nuclear polarization using light. So with light, you're able to pulse an object with specific metamaterial coatings. And we'll get to those metamaterial coatings in a moment. And that creates triplet state electron pairs. So on the bottom right, you can see there's the singlet state, which is the most common, doublet state, and then the triplet state. Triplet state is uncommon. And because you got two electrons that are basically bound together, it's kind of like Cooper pairs, they combine with the microwaves and increase the coupling of the ESR system. And the overall detected increase in NMR signal to noise ratio from this effect was 250,000 times over the thermal equilibrium base. So definitely very interesting thing to look into. And that's where we got this. It's our nitrogen laser. So the nitrogen laser, we're still working on this. This is a project that's still being worked on, but we're going to find a way to get this nitrogen laser probably reflected off of some mirror over here. We have to find a way to mount it. It's going to beam into that chamber, and
You
we're
got to
gonna
get a
pulse
laser
it.
table, man. Why don't you? You should have a laser table with all the
We
mount.
can't. There's no room here for a laser taper. It took us. It needs to be connected to here because there is no room for a
You
laser
could even
table.
just make you could make one with, so if you screw the mount, you get the
Yeah,
mount.
we're gonna have to figure something out and like machine something out in order to do that. But that's definitely something we're looking at. So the magic metamaterial that they suggest in order to create these triplet state electrons is a material known as pentacene. So you see that little purplish stuff over there? So this was Michael Perrone recommended that we mix it.
Back there. What is pentacene? No.
Pentacene is actually when you have a fire pit and you have that soot that's left over, a little bit of that, it might be pentacene. But it's really just a unique combination of carbon atoms.
Okay.
And it's kind of purplish, but it has just the right shape that when it's excited with a high energy beam like this nitrogen laser would create, it would create those triplet states, which increase the NMR signal to noise ratio by many orders of magnitude.
It's
other cool shit we have going.
It's a P-type organic superconductor known for its high carrier mobility and is composed of 5 fused benzene rings, making it a popular choice for use in organic field effect transistors and other electronic applications. Yes, sir.
Jeremy,
go on.
Can you guess what this is?
That looks like
Wow.
caterpillar turd.
It's a coil made out of bismuth.
I like what I see.
Are you serious?
That is a coil made out of bismuth. Yes. We cast bismuth in the shape of a coil. And not only that, while it was cooling, 51 amps were applied between these two terminals until it completely solidified. So
Okay.
the domains
Amazing
are
work.
oriented. It's got
Amazing
oriented
work.
domains. It's got 7 turns.
You
Oriented
did it.
domains.
Oh,
Yeah.
you
You
did it.
straight up did it right and proper. That's epic. I look forward to what comes of that.
I'm
So
gonna.
what we're planning to do with that, some of our team members have suggested that there may be some time change effect, like it. We're calling it the curious case of Jeremiah's time machine because
Oh yeah.
he wanted to call it the curious device, and I wanted to call it Jeremiah's time machine. So we call it the curious case of Jeremiah's time machine. Well, in order
Dude,
to
Jeremiah's
detect,
coils are insane. He's doing the.
so we're not shitting around. We
Oh,
wanted to detect time dilation down to the nanosecond. So we got a bunch of these rubidium clocks. These are pretty small, little rubidium clocks. They put out 15 megahertz signal. We're going to have a couple of them go out to an oscilloscope. One of them is going to be on the freaking, going to be on that, and the other one's going to be out as a control. And we're going to look at the two Fourier transform the waves, and we're going to see if they move at all when we energize that coil. Different ways of energizing it, and if that works, we're going to, have some interesting results. Now, the reason why bismuth is special is because bismuth is one of those materials that are diamagnetic. When you apply magnetic field, it opposes that magnetic field directly, almost instantaneously. In fact, they were never able to detect a lag, not even at speed of light, no
so what
measuring
did you
equipment.
use for a mold? Did you use like a rope and casting sand or something? How did you?
We didn't use casting sand. We used plaster of Paris, and
Okay.
it's kind of like a rope system, but we ended up having to machine it because the depth wasn't equal. So I put on a burr bit, this bit, and stuck it on here,
Yeah.
and we just like moved around and machined it out so that the depth would be equal
Okay.
as we poured.
It's a little rough.
Uh,
I would maybe take a rope light and curl it up
Yeah, the problem is that the
and
depth
pull it
that
out.
when you set it in
Yeah.
there, yeah, when you set it in there, it's kind of it's going to be deeper at some spots and lower, no, deeper
Yeah.
and
If
higher.
anyone
Like,
who's an expert in making molds wants to, make some custom molds for us to do casting with, please reach out to
I
it.
learned a lot from just
I
doing
actually
this.
have a guy.
Yeah, I'm just saying, I want someone who's a guy who's like in our audience that's like into this and is down for it and is not going to be like, I want full market price for my labor. And I want someone who's like down to be part of the team because I've put in enough on this and that we appreciate the super chats and everything. We've made not quite $100.
Oh man,
I need to make $700 by the end of the night.
I am jelly.
In the next 2 weeks, I need to make $700 if I want to go to this event that you were talking about, the US. Sorry, I'm going to bring it up on my screen again. The hackathon event for anyone who just joined. Deep
Guys, come
Prasad
on,
and
let's get Jeremy to hackathon.
yeah, I need to get to
Indeed.
hackathon.
We need you there. We need the Reese to be there.
All right, let's see. Boston to LA. Wait, no, it's Boston to probably fly into Oakland, right? Flights from Boston to Oakland. Let's see. Search how much. April 20th. Oh, I don't even know if I can get
April 18th to the 20th,
it. Jeez.
or 21st, 18th to the 21st.
That's too long. I can't go this soon. 2 days. So many days. That's a lot. Well, it's about gonna be about 500 and change. It's probably like $600-700, honestly, with everything. Yeah, so I need to make like $600-700 if I want to make this trip.
Jeremy, you got the wrong dates in there. It's the 18th to the 21st.
I don't know if I can get it.
The 19th, you can go to the 19th too.
Flights are so I'd have to get it tonight.
Yeah.
I don't think I can go, man. But damn. Well, I could probably maybe find another flight
500.
somewhere else, but 500. This
Come
is
on,
one
let's get those
stop,
super
though.
chats going.
I gotta stop in Denver. I had to do that another time. That's how I got to see the Denver airport and take a bunch of pictures of it. You ever seen that place?
It's creepy AF. I just gotta
Yeah.
say. At least the murals and the artwork.
Dang.
Come on, let's get those
My
super chats,
T-Brain.
guys.
Oh yeah, my T-Brain. Oh, there we go. Wow, 111.11.
Woo!
There we go. Now we're getting.
Let's
Now
get
we're
it going.
talking.
Let's get going. We're at $200 now, aren't we?
We just dwarfed all the other contributions so
Jeremy,
far. Man.
I'm putting that money out there. I want to see you there. If there is one person in the world that should be at the UFO hackathon, it's the freaking alien scientist.
I know, huh, man? Talk about, yeah, man. Jesse Michael's going to be there, and D Prasad. Yeah, these guys. I've talked to all of them. We've had them on the. We've had on the podcast before and stuff. So all these guys are. We've had many arguments.
Thomas, another $100. Shit, we getting Jeremy.
Yeah,
there.
we're getting there, dude.
Thomas!
Yeah.
This is what I'm talking about. I mean,
And
I can see David Wilcox. I watched David Wilcox go get 100. You ever seen a David Wilcox stream? He'll get like a $2,000 by the end of the night. It's ridiculous, man. He'll have like 10,000 people watching him from all from Ancient Aliens. Talk about
guys. This money is going to
all kinds of nonsense.
It's going straight to the airline. Jeremy's not getting rich off of you. He's coming.
Well, and YouTube. Don't forget, YouTube automatically steals 30%. But
30%.
We're getting, yeah. Hey, me, poor Canadian peasant. Your government also takes an additional 30%. So it's like I'm only left with 40 when I get my YouTube. Shit.
And then the taxes on the income too. You're down to like
right. Oh man, we're just.
But if there's one thing I can add to this. Jeremy, consistently, all these years, the decades that you've been putting into this, you are consistently years ahead of the curve of anyone else on identifying the exact mechanisms that are most likely present in these craft. You were years ahead on the tier 3B, you're years ahead on the arts parts. I'm finding stuff in arts parts that I had no idea that you'd even talked about these things until I start going, well, it looks like this is going on, only to find out that you're talking about that crap back in 2017, 2018. Like you're always on the cutting edge. So the stuff that they got,
Jared, we need a full breakdown of your arts part stuff before the stream.
I've forgotten more useful knowledge than I probably learned, man, over the years. And I've talked to a lot of crazy people that have come my way because this channel it's been a hub for that, and they realize that, they know that, man. You know that I had a guy.
What did you learn about plasma and polaritons, Jared?
Yeah, so I was looking into plasmon polaritons, exciton polaritons, and I was going, it really looks like these might be present in the thing. And then just last night, Tim reposted your APEC from 2021. I'm like, holy crap. Of course, Jeremy was already talking about this stuff. And of course, his presentation on it was amazing.
Yeah, man. I don't know, man. I think I'm going crazy
Cash
because
app.
I sit in the world and watch,
give out your Cash App.
Well, when you sit there and I should throw out my Cash App. Yeah, I do.
Several people are asking for it.
Oh my God, you got
it.
Yes, they steal a bunch.
Euro.
They steal a bunch. We're gonna do this. I'm gonna post this up. So this is my Venmo.
Yeah, if we could Venmo Jeremy directly.
People asking Cash App. couple people asking cash.
Yeah, I'm gonna do my Cash App next. Hold on, guys. Just keep talking about this event and what you guys know about it and
We
what's
are
going on
getting
there.
Mr.
It's on a
Reese into
submarine or
all of
on a
you.
Navy ship or
It's on
something,
the
you said?
Hornet. It's on the USS Hornet. It's on the aircraft carrier that's parked down over there, and we already got an Airbnb that's walking distance from it. So we're gonna be bunking up with the alien scientist so long as he can get a flight out there, and
Jesus, Mark.
there's gonna be a cash prize, I think, for the top contenders and venture capitalists. Guys, this is your chance to make a difference. Get Jeremy Reese to San Francisco for the UAP hackathon. I can't think of anybody who's more deserving to be there right now. I already bought a ticket, but I'd really love for Jeremy to be there.
Yeah, my Cash App is just money Jeremy Riss, one word. That's it.
And there's your Venmo.
Jeremy, can I share screen?
Yeah, let me put both of those up on at once. Yeah, I'm gonna add you to stage right now, Jared. Let's see what you got.
I just wanted to share the hackathon site here.
Why won't it let me? I gotta stop my screen. Oh, Mark's there. That's why.
There we go. Let me make this a little smaller. So it's sf-uap.com. It looks like they're going to be doing it on the USS Hornet, which is this big carrier that is sitting right next to Alameda. They got a bunch of quotes of people. It doesn't matter. But here is the 5 areas that they're going to be covering. So we have the material science, and mostly what it looks like they're doing is they want to get people who are experts in their respective fields. And since the hackathon, they want to see lots of simulations and code and all that. And after 2 days of working on these 5 areas, people are going to submit proposals basically for where they think useful research in this should go. And there's going to be 4 different VC companies present there. So you got the material science, where it looks like Nolan is going to be releasing some additional atomic level info on some of his materials. You got the Nazca mummies, which there's like 30 of these 6-foot tall mummies that they've recovered now. So you got the biology people showing up to this thing. You got the psionics side of thing, where they're trying to get not just, woo-woo people, but they're trying to get people who are big into wearable neurotech to be able to see if there's ways that maybe we can improve our ability to interface with these craft. Then you got the one that we actually really care about, which is propulsion. I feel like that's pretty self-explanatory on your channel. And lastly, we got, civilization simulations of some kind. I'm not going to even pretend like I know what's going on there. So then you got the judges. You got the judges, which is Dr. Nolan, Jesse Michael, and then Admiral Gallaudet. And there might be some more judges, but I think those are the 3 main ones. And I think it's Nolan and Jesse and Deep Prasad are like the 3 people who are like really putting this thing on. And lastly, let me just click on the propulsion thing. You can see what they're talking about doing there. They want people to come up with simulations that will replicate the actual signatures we're getting off of these craft. And they also want people to come up with simulations for how these craft are interacting with all these different fields, like RF fields, gravitational fields, atmospheric fields. So like Jim Segala over at the MUPAS, MUPAS, he has done some really good work that shows that these craft are affecting they're increasing the amount of gamma emissions up to 16 hours before they appear. So like either it seems like they're prepping the area before they show up. And then we have other info from like Ray Stanford from the 70s, where you have these harmonics of gravitational and magnetic alterations that happen simultaneously when these craft are maneuvering. So there's probably enough data out there that we could do some really good work with this. And I think without Jeremy there, the whole thing is going to be just less.
Right. Oh, crazy. Thank you for saying that, man. I'm honored by everyone that's reaching out to help me get out there, man. It's like, this would be great.
I have one thing to say, though. As long as one of the venture capitalists are not Sarvati Aerospace.
Is one of them?
No,
Is
I'm
David
saying as
Wilcock
long
gonna be
as
there?
it's
I want to make
not.
sure
David
Wilcock
Wilcock is
goes.
not invited. This is
Thank God.
legit.
It's
David Wilcock.
Imagine if David shows up.
let me share screen one more time.
They'll have to
here.
get another seat for his forehead.
So here are the four
Right, David.
companies. Let's see.
Jeremy, did you get any Venmos and Cash Apps?
I haven't got any yet come through on I'm checking just because I was going to announce them if people want them announced. You know, if you can send them private. If you send it private, then I won't do it. I won't share it. But
Yeah, if you send a Venmo or a Cash App to Jeremy to help him buy his ticket.
We probably got like 400 so far just from the super chats here. If take out some of that for whatever they take out. So I need probably another 400 still to go.
Did you mention Mr. Mars yet?
I should bring him on the stream because I have to this is the other thing. I have to make sure I get permission from my wife to leave a newborn baby and go to this event, for like 2-3 days.
Don't forget it's over Easter too. It's on Easter Sunday.
It's on Easter? Well, that might be all right.
Easter.
Yeah, I guess so. Man, this is crazy. Easter Sunday. What an event. And is this? I got to come up with a presentation. What is this? You can enter. So what is this? A hacker. Apply to become a hacker and get access to exclusive data and resources in connection to our created missions. Be part of a historic hackathon. Also win some cash and exclusive access prizes. That's
so you can go for free as a hacker, right? Which is what you should do. Then they also have like VIP things where you can go talk to, I don't know, Nolan and Gallaudet and whoever.
Bro, they should give me an honorary VIP just for.
Any scientist is VIP. So
most of these events I go to, I usually talk to the director of it and like get that. I usually
at least
do.
Get a media pass. But I think you're going to need more than $800.
Steve Ellswick did my first year at Tesla Tech. Yeah.
How much do divorce lawyers cost these days? Like, what? Just kidding. Just kidding.
We need airline ticket money. That's all we need right now. We
exactly.
already got his
Your wife will understand. Your wife will understand. You can only go 2 days.
You'd be jealous that she can't come.
Yeah. Well, the baby, I know you can't bring him. You can't really do that.
You can't really bring a baby that young, no. But she'll come. Angie will come in the future with Mars Dangerous.
Yeah, dude, Mars Dangerous. It's the coolest name ever, dude. He's destined to be the first man on Mars, maybe.
Events, are you guys doing Tesla Tech this year? I have confirmed that I will be doing a presentation there and it's helping Steve run some of the media aspects. So,
have you ever been to Tesla Tech before?
No.
You're gonna love it. It's right up your alley. You'll be competing in many different arenas there. It's not like as serious as APEC is, but it casts a much broader net.
Yeah,
and
more of a
I think yeah, it's more of a trade show for all things exotic science kind of stuff. I think you'll like it.
My partner Mike Gamble goes every year. He's been going for lots of years. My buddy Isaiah with the SEG, he just went last year. It's worth going at least once.
Yeah, there's a few presenters there this year I want to see.
Stay away from Paul Price.
I have his book, signed copy.
Oh yeah.
Yep.
Good
Can't
for
forget.
you.
You can't forget that guy.
Oh, you can't forget him.
You cannot forget Paul Price, man. And his dad was the original Roswell recovery team and buried the pieces under some driveway. And according to Paul, you know, it was
Can I plug the arts parts stuff?
yeah.
Absolutely
Speaking of
love an update on that.
what's going on
So-
with that, you're finding structures and interesting things in that little tiny piece, are you?
Yeah, so I got the chance to test 3 additional arts parts samples, as well as 2 samples from the San Augustine crash, which happened like a day or 2 before Roswell. I got to test those at a really, really high-end lab with really high-end equipment and really smart people. And I'm not allowed to divulge some information about that just yet until the white paper comes out, which hopefully is going to be sooner rather than later. But no timeline on that. But
Exciting.
I can tell y'all what I have seen, because who the fuck am I, right? So one really cool thing I saw. I will draw a picture is what I will do. Give me a second.
Hey,
right.
so by the way, will you get that? I just want to point out one thing really quickly. Where was it? Oh yeah, here it is. Let me just I just want to share this real quick. So with all the technology and stuff we've discussed on the show, this is apparently we already cracked this in 1954 according to Stephen Greer. So I just want to play this commercial from Chevy from 1955, a year after we cracked
This is
anti-gravity.
grand. I've never had a car that steers like this 55 Chevy. It's so wonderfully easy to turn.
You're so right, miss. That's because the Motoramic Chevrolet for 55 steers on ball bearings. Chevrolet puts a whole bunch of little steel balls in the steering gear, like this. They stick out beyond the steering gear shaft, act just like the threads on a big bolt, except there's practically no friction to a ball bearing. It moves easy as pie.
Chevrolet's the only car in the low price field that steers on ball bearings. Chevrolet's tops in maneuverability, too. The only car in its field that can turn in a diameter of 38 feet.
Visit your Chevrolet.
If they figured it out then, why the hell can't you guys? I don't think they did, but I think Greer's got to check his information and needs to.
I disagree. I think they did.
You think they did?
Yep.
Then why can't you do it?
I did it.
You did it.
I already did it. I mean,
So you think they already figured this out?
they had a team of scientists using latest the latest technology and theory, and they tried a lot of stuff. I'm pretty much a one-man team over here. I have some people that come up and help out, but they are asking me what to do. I think we've already cracked it. I've already shown a connection between dynamic nuclear polarization and mass. Getting those numbers up is the next step, and I think that's what they were doing. There was also electrostatic effects that we've already proven to work, and those are all those things were available back then. They were cutting edge. They were, relatively new technology. Nowadays, you can't even use the new technology for the stuff. You have to go back to the 70s and 80s to get your traveling wave tube amplifiers in order to do this kind of stuff. Modern technology doesn't work very well for this type of research. It's all solid state.
Let me show you all
Yeah.
something that a very
Sorry.
small handful of people have actually seen, right? So right now on Jeremy's channel, y'all are going to see something that I've drawn here, which is reminiscent of one of the most important images that I am not allowed to share. Okay, so here we go.
Exclusive.
Under the transmission electron microscope, right? So we're looking at individual atoms, right? We're getting real small. This was one of the most important images that I feel as though I saw. Now, the material scientist who was doing the work is like, those could just be grains. We don't know. Maybe, but I analyzed the crap out of every single bit of data we had, and I'm pretty convinced that this is not. So the scale for size reference, this is about right. 50 nanometers is about that big, right? So what you have is in a little chunk, a teensy tiny little chunk taken out of the magnesium layer, you have these particular shapes show up in one spot. And they are pointed towards each other. The length of this smaller one is equal to the width of this upper one. And they're, like I said, pointed right at each other. Well, it turns out that in certain RF situations, this is called a bow tie resonator. It has a very specific application for signal transmission. So there's other stuff present in the arts part samples that makes it look like there might be a lot of plasmonics, a lot of light matter interactions occurring within these materials. Additionally, it looks like there's a couple different mechanisms that are adding angular momentum. They're twisting the signals that are propagating through the materials. But in addition to all those things, there's this. Now, the reason why this is so important, the reason why I'm so like, oh my God about this, Arts Parts came on the scene in 1996, right? So even though it's supposedly from the Roswell crash, the earliest chain of custody that we can reliably say is 1996. So if we find anything in here that could have been made in 1996 or earlier, it's less cool, right? But if we find stuff in here that there's no way it could have been made in 1996, that's like a holy crap moment, right? Okay, Downogorsk, Russia, 1986. That was like their Roswell event. It happened 38 years after the actual Roswell event, right? So in Downogorsk, Russia, 1986, they have this UFO crash into these mountains that are being used to mine all sorts of rare earth materials. It crashes into this mountain, and like everybody in town sees it happen, right? But it's super snowy and icy and windy, so they can't get up there for a few days. They go up there, they recover a bunch of pieces of this craft, but the whole craft itself like disappeared. The Men in Black came and got it, or the aliens came back and got it, whatever. There was just pieces left. They didn't clean it up very good. So the pieces they recovered, though, look very, very similar in some ways to the Arts Parts. That's the first indicator that, wait, is this like the same type of craft? The second indicator, the elemental analysis of the parts that they had, oh my lordy. There's like 9 elements that are the same elements, to include lead and bismuth. It's very, very interesting. So there is a negative 0% chance that this was a thing in 1986. 1996, like, we're at 1%, right? We're at 1% chance in 1996, which that's too high for my blood. 0%, now we're starting to get interesting. We're like time travelers or breakaway civilization or whatever other explanation. But if Arts Parts did come from the Roswell crash, and the Downogorsk 1986 can predate our Arts Parts at least back 10 years. This nanotech present, that is what makes it amazing. Bowtie resonators.
Yeah, fascinating stuff, man. That's maybe a key find in this. Looks a little deformed or slightly, but you have that baseball home plate shape on the top, and then what looks like a maybe like a bowling pin or what is that? What would you call that?
I thought it looked kind of like the Volcom. The Volcom.
How does a bow tie resonator react with microwave fields?
Well, we're not dealing with microwaves with this thing. So there's like 6 different things within the Arts Parts material that all seem to be tuned for 1 to 4.5 terahertz. Now, most of that seems to fall closer to 2 terahertz. And it seems as though some of the papers I've read, it seems like it is the second harmonic that is where you get this gravity interaction.
Well, this is
Guys,
what
I'm about to show you. Jeremy, make this full screen right now.
Well, this
I'm going to show you something really cool. Give me the full screen. Check this out. We have a terahertz laser. You heard me right. This is a terahertz laser. It goes from 0.25 terahertz up to 7. And we're in the process of refurbishing it. The thing is about 8 feet long. And we got a water chiller for it. We got some other stuff. I'm gonna have to have Jeremiah's friend come down here to help me set this up. But this is a freaking terahertz laser.
What, dude?
Yes, we finally got one.
Oh
Jared
my
found it on
god,
eBay.
dude!
We
Now
picked it
it's
up.
like,
It came from Los Alamos, I think. That is a
Wow.
fucking
India.
terahertz laser.
no, dude.
Wow.
Do you need a
And we
permit
picked
for
it up
that
for a
thing?
steal. It was like $2,500 or something like that. And this thing is
That's
normally
insane.
like hundreds of thousands.
Of
Don't
course.
point that at your face.
That's it. That's it. It's a terahertz laser.
Oh my
We
god!
finally got one.
Yeah, it's
Look at
the
the size
super
of-
duper like class 5 dangerous level one.
Oh
That's
my
the
god!
size of. Well, let me get in there. That's the size of the opening. Oh shit!
Jesus. This should have remained classified, you guys. Now they're all going to be on to us.
So you're looking down. You're looking down the barrel of a terahertz laser.
Oh my god! Look at that stabilizer. Oh, what the beam shaper?
It's
Beautiful.
using a massive 100-watt CO2 laser, and then there's some mixing of gases, and it basically uses a beat harmonic between
Yeah,
different lasers in order to create the terahertz.
yeah. You're on a list now, boy.
I've been on this. But well, I had the FBI walk in through that door one day.
Yeah, I know. I remember that.
Then they ended up on the news. But yes, terahertz waveguide, terahertz laser.
That's absolutely epic.
Yeah, thanks for the publicity, guys. At the our fellows in the government, the black,
So
whoever called on us, damn it.
the nifty thing about the arts parts stuff at the nanoscale as well is that it seems like there might be quantum dots in there. Maybe quantum dots in there.
Yeah.
And
Yeah, we
quantum
need to get
dots-
some. I'm gonna get some we got to get on Joel to get us some. We've got a terahertz laser shirts, and we're just gonna wear those to this thing. Do you want to do that, guys? If I get 3 shirts made, we
Yes, I'll wear it. Yeah.
We've got a terahertz laser. Ask me about my terahertz laser.
So these quantum dots can convert ambient heat into coherent terahertz. That's a really interesting thing, is that the craft itself seems like between all these different things that are tuned for this range of terahertz, they're very symbiotic, right? So you have the material over here creates some heat at a certain, ambient, like white noise heat, right? And you have these quantum dots that take that and they turn it in from incoherent heat into coherent terahertz heat or phonons, right? And then those terahertz phonons that you're directing through the material start interacting with that material in a way that produces heat, that produces more terahertz. So now you have this cyclic action of the material is able to, because of the embedded stuff inside it, is able to create its own stimulus to be able to do it. Now, obviously, it's not perfectly efficient, right? You have losses, but there's probably a couple patents to be had in that.
This is a new kind of. This is how quantum computers are built. I believe it. It's about arrays of these types of resonators on the nanoscale. So you get a bunch of these nanoscale resonators in arrays, and that's how you can send signals and all kinds of stuff through a quantum computer, and not have mess ups of the orientation and the entanglement, faults, which is the biggest problem we have with our current attempts at building quantum computers. But yeah, there's a ton of stuff on these bow tie resonators. I'm finding fascinating discovery, Jared. Thank you for sharing that with us, and I can't wait to point a terahertz laser at that thing and see if we can get it to float. So imagine that. Imagine if we get
point it at your bismuth coils, the Jeremiah time machine mystery or whatever he called it.
Oh, the curious case of Jeremiah's time machine.
Yes, that definitely needs to be in a couple of your terahertz laser experiments.
TTSA in their documents for what they say, the tech they're trying to get out of the UFO materials that they have, it seems as though they were more interested in the cloaking side, which makes me wonder, and that's after they had submitted it to DevCom, Army DevCom, right? So TTSA gets the sample from Linda. They give it to the Army because the Army has the terahertz laser. Army tests it, finds some cool shit that we don't know what they found. The rumor is there was propulsion, but it may have been something else. And then it went from them over to Arrow, Oak Ridge, Dirty, everything. So whatever happened at Army DevCom is the thing that then TTSA writes up their paper that says, these are the texts that we think we can come up with from this. And the one that they seem to hammer on is the cloaking side, which would make sense. From Sadog's tests, it looks like the material is insanely good at radiation cloaking. So maybe it has the ability to cloak multiple things. Maybe it cloaks both radiation, like nuclear radiation, as well as some kinds of electromagnetic radiation. And maybe even better, it can take incident radiation, like heat or radar, and it can convert it into some usable something, right? It can harvest.
Oh, wow.
That's what I talked about. One of my first videos was the idea of using all these like capture crystals with these layered photonic band gap materials to kind of filter off all the different frequencies. You know, yeah, that would be kind of amazing, because then you could just like take all the ambient energy and just use it to full advantage if possible, and that would be perfect for
energy right there.
That's exactly what DARPA was trying to create with the Power Everywhere thing that I talked about in the last stream. That was on the DARPA channel. They're building these, they're building these blimps, which are like power stations, and they can shine a laser at it from really far away, and it absorbs the energy and stores it. That way, they don't have to like deliver, gas, and because it's in the future with drones and everything, you're going to get a tanker plane into a hostile airspace to refuel. No, you're going to have to. That's not how the future is going. We're talking about drones and way to get drones to have indefinite, hover indefinitely, right?
Also, the terahertz band gap, the terahertz forbidden band, that is 6G. Whenever you hear people talking about 6G, Trump got a bunch of flack in his last term because he started talking about 6G, and people were like, that's not a thing yet. Well, in China, they're ahead of the curve, and it is a thing. So 6G is using these single-digit terahertz for satellite communication, specifically between satellites, but also specifically surface to satellite. So there's a lot of applications for single-digit terahertz stuff. One of them is communications and data transfer, like 6G. And there's a lot of biological interactions that occur at that range as well. Like there's 1,000 miracles that happen in single-digit terahertz.
And isn't that a kind of a risk? And Mark, you got to be careful around operating that terahertz laser.
It's not just bad stuff. Good stuff can happen too.
What else do you got going on here?
So this was the pentacene paint that we had going on, the laser, which I actually just showed you. That's the nitrogen laser. I like to call it my Jewish space laser, no, anti-gravity paint that's powered by my Jewish space laser. The nitrogen laser, of course, would be the only laser that could possibly short out the ionosphere and explain that crazy anti-Semites Jewish space laser conspiracy theory. And this is our next steps.
True? I thought that was just a. Oh my god!
No, it's not true. So this is the next steps. What we're trying to make a microwave cavity with the magnetic field that is internal to it. In order to make a mini spacecraft, we actually have a 3D print of this up on the shelf over here. Let me take the laptop again and show you guys. I actually have a prototype of that up here. That's our 3D printed model of that. Let's get back to the presentation, Jeremy.
Sorry.
And other projects that we have going on. This up over here, this is the warp drive device. It's basically standing waves in space. And the big connects thing on the left, that's our latest version of the rotating electrostatic field generator, otherwise known as the invisible wall experiment. And here it is. It's
Yeah.
made out of connects because connects are plastic, cheap, and dielectrics. And I had lots of them. So when I power this up, the Kapton roller spins around. As you can see, I could rotate it easily, and it's connected to a little motor down over there in the corner. And the field spins around. I apply a high voltage down over here in the base, high voltage to the Kapton. It starts to spin around, and a field builds up, and you can actually feel it from a distance. But here's the funny thing: as you approach the field, you destroy it. So if somebody were standing right here inside the field as it spun up, not much would happen. But if
Dissipating
everyone
it.
was standing back and allowed it to build up, the field will build up, and it would be about like 5 feet in each direction. It builds up until there's something conductive that it comes in contact to. Then when you throw something through it, you're kind of shorting out the field. So there's a little bit of energy in the field that stops things. And it kind of works exactly as they describe it on Star Trek, that, you know, the fields get weakened as they get hit by objects. It's not like a physical barrier. It's more like energy building up in this rotation vortex. And as things move into it, they get pushed back because they're dissipating that energy that's in there. So the next steps for this thing is we're actually trying to make the this Kapton is now like at 5 inches. We want to get it all the way up to 24 inches. So we got another roll of Kapton over here. This is going to be the next roller.
Yeah,
And
absolutely. You need that.
I designed a much longer Connects roller over here. This is using like some of the black parts, which are super
You
stiff.
don't have enough width on the surface area. I mean, the 3M tape factory was like these wide ass sheets of cellophane. They're probably like 7-foot rolls. What were the width of the rolls on the
That was like
3M
20
factory?
feet.
Yeah,
and
they were super wide. This one is 21 inches. It's about as wide as I could find it. So if it doesn't work with 21 inches, I'm probably going to throw in the towel on this. But so far, we already saw it work with 5 inches. It wasn't a very strong effect. Michael
Right.
Perrone was here with me when we powered it up, and
you're shooting ping pong balls at it with that ramp, right?
Yeah. But we weren't shooting them. We had them going down this highly calibrated, and it's calibrated because it doesn't change. So every time you drop a ball, and there's a little trigger mechanism over here, make sure not to move anything. The ball lands with precision in the exact same spot every time. But when you power on the field, that spot moves. So that's how we know that it actually is working. But it's not a very strong effect. The thing needs to build up a pretty strong field. Everyone needs to stand back for it to work. Obviously, this is not even a prototype. This is a proof of concept at best.
So we're not blocking photon torpedoes on the Starship Enterprise.
So you're not going to be selling Connects force fields anytime soon.
No.
Maybe we will. The Connects force field kit would be a pretty cool Connects kit to have.
Right. Well, I guess
Like, can you imagine if you could build a Connects anti-gravity or invisible wall force field generator?
Let's reach out to their marketing director and see if he'll go for it on
Oh, guaranteed. You just gotta, get the field working, and boom, they'd buy that.
They'll probably do it, dude. They're probably like, all right.
They'd have like 3 in every store. It would be their windows. I guarantee.
People have kids. I mean, it's going to be an expensive thing, though. The kit's going to be like a two.
Oh my God! Don Thomas, $400, Jeremy. You be going out there.
Yeah, that's a record. No, I think I think I had a record higher than that before one time, long time ago.
Well, let's take a moment and give a huge clap. Don for the win.
Most of my trip right there. Oh my God,
Jeremy. Get on your get on that website and purchase a ticket right now.
Yeah,
I think plane ticket for Jeremy.
At least another $50 though for flowers for the wife.
I gotta
Hey,
confirm.
and a nice date out. My God, come
Oh
on.
my God, I'm gonna have
But
to, like, she's been stuck in the, well, she's not stuck completely, but not.
he just
I'm
won't be
gonna
allowed to stream for 2 weeks after he gets home because he'll be on baby duties. That's how it works.
see JetBlue. All right. I'm gonna go look into this flight. I gotta ask permission. I gotta ask permission before I do that, but I gotta get it
Right,
done
there you
right
go.
away now. Holy crap! I think that did it, man. Wow.
Wow, I can't believe it. Jared, we did it.
Don, amazing.
Wow.
Everybody who donated.
Don Thomas,
Huge.
thank you for making it
Wow.
happen. Jeremy's going to be in San Francisco for the UAP hackathon now.
Oh God, I have to go now. I'm gonna tell her, like, I'm in for it now. I had people donate like $700 on the stream. That's amazing.
And Don
That
gave
is amazing.
$100 before that already. So Don is basically buying your ticket.
Yeah, she is. She did. Don,
Huge support.
that's
Next
huge
level.
support. That is huge.
This trip is dedicated to Don, getting Jeremy there.
This is it. And you guys stepped up to my challenge, so didn't back down. That's and I don't do that. I'm not like grifting all, I'm doing this all the time and stuff.
Oh, Brian Kelly!
Kelly for the wife. There you go.
Brian,
Yes, Brian Kelly.
You didn't have to, bro, but thank you. Jeez.
Thank you, Brian.
Give me some extra.
I know
hotel
Brian.
money.
We met. Brian showed up at the lab a couple times for some of the meetups.
Brian's amazing.
A couple bucks for the
Like
Uber
Brian's
and
cool.
some drinks at the reception hall, right? So yeah, thank you. I appreciate that, bro. That's boom shakalaka with styling now. Oh my God, I'm gonna meet Deep Prasad and Gary Nolan. Now they can't like they can't run away from me.
This is amazing. We're actually doing it. We're getting the
believe
game
that it
back
happened.
together.
It's awesome.
I can't believe that happened. That's amazing. I thought I didn't think people would pull up to the challenge.
That is incredible. Wow. What a good community. What an awesome community we have here, man.
That really brings my faith back to this YouTube community. I didn't know what would happen today.
180 people watching right now. It's not like, a huge crowd, so that's some dedicated.
The work you do is clearly appreciated.
I damn well I'm gonna try to stream it if I can. If I got an Ethernet connection, and oh yeah, this is hilarious. I can't wait.
We're gonna come with cameras. If we can't stream it, we'll copy.
Yeah.
We'll get some footage and upload
I'm gonna
it.
get good footage. I'm gonna get some good interviews, and I'm telling Jesse Michaels is gonna interview me for his podcast. It's gonna happen when I'm there, dude, because it's gonna happen.
You guys are just gonna corner him and be like, "This is now."
No, I don't need to corner him. I have his number. I'll just tell him. I'll text him right now and tell him I'm coming, bro. Like, dude, it's
we even got donations for the drinks.
This is great, man. Oh wow, this is incredible. Yeah, we're gonna. I want to see everyone work together, and I've never I've always been for pro transparency, pro openness, and like disclosure, and I'm not gonna start any fights with Gary Nolan over COVID-19. It's not the place for that. It's just we're gonna focus on the anti-gravity and the task at hand is getting humanity to the next stage of our evolution. So that's where we need to go, and this is the way. This is the way ahead, man. We can't look back. We can't listen to guys like Bill Gates tell us that we need to depopulate and eat reduce cow farts to save the planet and everything, man. We can get off this planet and we can just and everything could be awesome, and we can again, health advice from some of these people that just don't look like they are the healthiest people. But yeah, this is crazy. It's just crazy everything that's going on right now. This is quite a year, and it's gonna be awesome if we get. I gotta get out there, man. So I'm gonna go talk to my wife right now, very nicely, and see how this
Beg
goes.
and plead on one knee and
Maybe
promise.
the internet gave me $1,000. I have to go.
Yeah, I have to book my ticket now so that before I lose a flight until I can't find a flight anymore. All right. Well, I think I'm gonna close it down here for tonight. I think so.
Wait, there's something. Yeah, there it
Oh,
is.
geez. Right.
Well, shout out to Ashton and shout out to
Shout out
Don.
to Ashton, yeah, for how Ashton's been here for us a lot of the way, man. He's really popularized a lot of the science and the technology. I've been kind
Covers
of
it
burnt.
well.
I've been burnt out, man, and Ashton's just been like carrying a torch on all this stuff when I've kind of been like, I've done it so long and so heavily for so many years. It's just it wears on you, man. It's not like, and also I need to make money and support my family and stuff. And this stuff is I have to go out and do real jobs and to make real money to get
I feel you.
fund all this, because it's not, these terahertz lasers are expensive, man. How much did that thing cost, by the way? No, I don't even want to know.
It was like $2,500.
Yeah, they
No,
got
it's
it for
less
a
than that.
steal of
That
a
was
deal.
$2,000.
Oh, huh?
Yeah, we got it at the
You got it
kick
at
it to the
1%
curb and pick it up.
price, 99% off. Like,
Yeah,
that's
we got
wild.
99%. We got the 99% off deal. In fact, we probably the crate that it came in probably had about $150 worth of lumber in it. It was like made with solid plywood. It was insane.
Mark is normally known as the king of eBay in our group for if he
Yeah.
pays more than 30% of the normal price or something, he's slipping. This terahertz laser might just give him a run for his money as one of the best eBay deals to enter that shop.
Well, Jared actually found it.
It was a
Thank
team
you,
effort.
guys. You're too kind. If we do discover something, then I'd be like,
When you do discover.
when? Yeah, when. We've discovered a lot of stuff already. Let me tell you what, we've showed a lot of stuff. We've revealed a lot of important science and really whacked our way through a lot of weeds. There was quite a muddy pool of weeds when this all started, right? And we've really shown the path. We don't have to wait for the government, because at the end of the day, when you want the government to give you answers, government goes to scientists to get those answers. And we go to the scientists and not all of them have the answers. And these are the questions of the stuff they don't have the answers to.
Jeremy, you remember 4 years ago when this was the tech we were working on here?
This is it, man. This is
The
paving the
EPR
way.
NMR laminar spintronic alignment rig. I gave Jeremy the task of naming that thing, and that's what he came up with.
Yes, we're gonna. I love coming up with names for stuff and acronyms and all that. That's. I love that kind of stuff. I got a new song for you guys, by the way. I don't know if I should.
Oh, rip it out! Come on.
Before I end.
I think the chat has funded a song to end it off with tonight.
Yeah, I guess you guys paid for this. It's not ready. I mean, I only have like the first verse, but I'm working on it. But I'll at least end it off with this fun little song that I've been working on. Yeah. Have you heard of Eli Lilly or a place called Sandoz Labs? Well, this is where the CIA bought all their acid tabs. They called it MK Ultra. The year was 1953, and a man named Sidney Gottlieb bought 500 grand of LSD. It was the entire world's supply. They were getting soldiers high. They parked on Hyde and Ashbury and gave the Manson family rides. They even went to Harvard, and that's when things got starboard. Ted Kaczynski was a genius who they drugged and called retarded. And soon that man became of Unabomber fame. The CIA's Henry Murray, you can go look up his name. It's a true story. Anyways, I hope you liked it.
That was amazing. What amazing stream. Epic work, Mark, Jared, and as always, Jeremy. Epic, you're going there, all three of you, and it's amazing.
4 of us, because Tim's coming too.
Oh, damn, even better.
Awesome, guys. All right, thank you. Have a good night, everyone out there, and thank you so much, especially to our star of the night, Don Thomas, for that $500. Like, oh my God, you paid for my trip, so I have to go now. And this was an epic stream, not just awesome, epic. Thank you all, and have a awesome night. We're doing this. I can't wait. This is going to be legendary when we go to this conference and cover this, dude. It's like all the UFO, UAP science hack people are going to be there. This is amazing. Way to go, team. Way to go, everyone. This is great.